So the cool part about this program is that it eliminates the problem with actual experimentation, like when you actually run voltage. Because when you actually run this in a lab situation, you have resistance in the wires, you have internal resistance in the voltmeters, and you never get like what the theoretical value is. So the theoretical values are based upon these completely ideal situations. So, but the cool part about this lab is that they take all that into account and they base it off of theoretical values. So the main thing is up here at the top. These are the E0 values that you have to use to match what the program is using. Okay? Don't use any other chart. Use this. Okay? Because this is what the program is built upon. These specific E0 values. So the cool part about this is that, and this is the first cell that you're going to build. So you're going to have silver nitrate and silver, and then you're going to have zinc and zinc nitrate on each side. So not only can you do that, but you can eventually change the molarity. So on that molarity column, you can change it from 2 all the way down to 0.001, and then the same thing over here with that white beaker, you can change that. So that's why this is a cool simulation, because then we don't have to worry about trying to go out and mix up all of these different dilute solutions, because we can just click a button and go, oh, here it is. Okay? So I generally hate computer simulations, but this one actually works because this makes sense. But this way we don't have to worry about the lab and the solutions getting in the way of the science. Okay, so now we can just focus on the science and not, hey, let's mix up these dilute solutions, and then we don't get the values that we were supposed to because there's resistance in the wires and resistance in the voltmeters. And somebody's going to knock over the solutions, and then what do we do? And it's just awful. So, did she leave again?
Yeah, she had to cough. I think
You had to cough?
So,
no, as soon as the doors were shut, I just heard her cough really loud. So.
Okay. So, let me kind of get you through how I wrote this lab. So you're going to start off with silver and zinc cell. Silver's on the left, zinc's on the right. Initially have these under standard conditions, everything being 1 molar. It doesn't default to 1 molar. You have to choose that concentration to be. You okay, dear?
Yeah, I swallowed wrong.
Okay. All right. So, with that said, so you're going to run this under standard conditions. In big bold letters, I put number 6. Turn off the voltmeter to reset the program. So you're going to run this under standard conditions. But basically, you have to tell the program to start back over. So what you're going to do, and you have to work this in the sequence. So you're going to take the left cell, the silver cell, and you're going to drop that concentration. You're going to take the zinc cell, and you're going to raise that concentration to 2. So then on number 9, again, you're going to calculate a theoretical value based upon the Nernst equation. And it's going to say, hey, what this is going to happen. Now, if you really want to make sure that you understand this, if you just look at changing the concentration, and if you want to think ahead of time, it's like, okay, hey, here's my standard value. Should this go up or should this go down before you actually do the calculation? That's going to give you like a true indication, like, do I really understand what's happening on the chemistry side of this? So then you're going to switch it. Then you're going to change the silver cell to the higher concentration, and then you're going to set the zinc cell to the lower concentration. And again, think through, hey, what's going to be happening? Should my E go up? Should my E go down? And why should that happen? On the back side, yes, there is a back side. So on 15, you got to explain why the voltage dropped or why the voltage increased. Again, okay, just don't say, well, it went up. The whole point of this is you're explaining why it happened. And again, you can explain it in terms of the desire for the electrons to move based upon concentrations that were already being crowded. You can explain it mathematically. Oh, this change made the Q go up, made the Q go down, because you're dividing something like that. When you get down to that part 2, now you're going to build a concentration cell. So this is what we just talked about. So, and when you get to number 1, I tell you, you will eventually not stay with the spirit of the lab. Okay? You're going to take a 0.01 molar and you're going to have 2 molar. Both of those are going to be silver and silver nitrate. This is just a straight concentration cell. There's no longer zinc involved. Everything is going to be the same except for the concentration. So you're going to calculate the theoretical value for E based upon the Nernst equation. When you have a concentration cell, what's the value of E naught?
0.
0, because if you have 1 molar and 1 molar, there's nothing to gain because everything's in equilibrium. So then when you get to number 6, what would happen when a voltmeter of hydrochloric acid were added to the cell on the left? Okay? Keep in mind you're going to add hydrochloric acid to the cell on the left. You have to pay attention to which cell you're adding it to. Okay? And look at what's going to happen to the concentration of the ions once you add hydrochloric acid. Then to give you a hint, it might involve a precipitate. Okay? When you get to number 7, you do the same thing. The only difference is with 7, you're going to use magnesium. So you're still going to build a concentration cell, but instead of having silver, you're going to do the same thing, but you're going to use magnesium. You're going to look at, hey, what's going to happen to that based upon the fact that it's magnesium. And then you're actually going to build it, see if what you predicted was correct. When you get down to question number 10 on the bottom of that second page, okay, when I say, regarding the magnesium cells just built, which one is the anode, and explain your answer and just don't say, that's where oxidation occurs, okay? Why is oxidation happening there, okay? That's what you want to explain. That's why I said, just don't say, oh, that's for oxidation. That's why I said, do not write that. So help me God if you write that. I'm just going to flunk it. Okay, I'm done. You're on your own. If you get done with this, you don't have any homework. So that's all we're in. This is all we have. So you're on your own.